Hi, let's have a look at areas. Today we're going to explore the formulae. The area is the amount of space inside the boundary of a shape. We can calculate this by counting the number of squares. The keyword here is inside. The types of squares we're going to count could be 1 centimeter squared or 1 meter squared or other something squared. The little 2 there gives away that we're looking at the area. Let's have a look at these 3 shapes. For instance, we can count them like so. Here we have 2 rows of 3, so 2 times 3 is 6. These are 3 rows of 2, 3 times 2 is 6. And here we have 1 row of 6. They're actually all the same area. And we calculated the area by going length times width. So the area of a rectangle is L times W. So that's a shortcut of. So when we do L times W, we don't have to sit there and count 1, 2, 3, 4, 5, 6. It gives us the answer much more quickly. So we're going to use that for all the formulas today. A special type of rectangle is a square because the length and the width are exactly the same size. So instead of going length times width, we can just say length times length. Let's have a look at triangles. I'm going to make a copy of it and manipulate this one. Now I'm going to label that one as B for base, and how tall it is, it's the H for height. Now we can turn this into a rectangle, and that way we can count the squares a lot faster. Can you guess how we're going to turn it into a rectangle? Let's have a look. So these two, you can see that they're the same amount of space, but this is a lot easier to calculate. How would we find the area of this one? We would say that is easy, that's the same as B before base, but this side, it's no longer the height, it's half the height. I've cut it into 2. So the area of this is half height times base, and they're both the same. So the areas of triangles, we can work them out by writing half height times base. And in books, you might see them abbreviated as half H times B. Oftentimes you'll see half B times H, but I like to write H first, it doesn't matter. So memorize the first formula. A question I often get is, what happens when the triangle looks like this? Now the base is there, the height is from the base to the tip, so see the height. Will we get the same formula? Let's see, let's move that piece over here and let's flip that over. It's the same rectangle. So yes, half height times base. So it doesn't matter what your triangle looks like as long as you do the height times the base. Notice that these two values are perpendicular to each other, or in other words, 90 degrees to each other. So don't use the side of the triangle, always use the height of the triangle. Next one, parallelogram. This one is easier. You can see that we can cut this little corner and move it to make a rectangle. So the formula for the parallelogram is the same as the rectangle, it's just the base times the height. Trapezium is a little bit trickier. How would you cut this to make a rectangle? Let me show you. Now let's have a think about how do we work out this area now. The height is now half the height of what it was, and the length is not just A, but also whatever that purple line was. So it's A plus B. So we have half the height times A plus B. So the area of the trapezium is half height times A plus B. Kites. This one is pretty easy. So I'm going to do duplicate. I'm going to move this triangle over here and that one over there. And now we have A times B, so the diagonals of the kite, but I have to make A half because I've only used half of A. So half A times B is the area of kites. Let's see if you can remember all the areas we calculated. So the area for squares is L times L. For rectangles is L times W. For parallelograms is height times base. And notice that all the letters we're using are always perpendicular to each other. So not the side of the parallelogram, but the height of the parallelogram. I can't pronounce it. And what was the area for triangles? Half height times base. For the kite was half A times B. And for trapezium, half height times the A plus B. You might have noticed that I've put them together because they have something in common. These three have half in the formula, whereas the other three formulas didn't. Another thing that all of them have in common is the length and the width, so the A's and B's or whatever you're multiplying are always 90 degrees to each other. They're never at a different angle. Be careful with that. All right, memorize them and I'll see you next time. Bye.